So, you've learned how to factor polynomials so that if you've got something like x squared plus 8x plus 12 equal to 0, and you want to factor this polynomial, having done lots of this, you know that you first have to find the integer factors of 12, which are 1 and 12, 2 and 6, 3 and 4, and then all the negatives of that. Negative 1, negative 12, negative 2, negative 6, negative 3, and negative 4, right? And then you've got to pick the pair of those that add up to 8, right? Which are these two. And then you can say x plus 2 times x plus 6 equals 0. And then you know that you can find two solutions then for x. Either x plus 2 equals 0, and therefore x equals negative 2, or x plus 6 equals 0, and therefore x equals negative 6. And those are your two solutions. And every time you do this factoring, you find two real solutions for it, right? But I am now going to talk about the limit of this factoring method, because you can't do it with all polynomials, not by a long shot. For instance, what if you have the polynomial 3x squared plus 6x minus 15, and that's equal to 0? Well, just like before, you would probably try to get rid of this 3 first. Divide both sides of the equation by 3, and you get x squared plus 2x minus 5 equals 0. And then you would look at the integer factors of negative 5, and you get, what, negative 1 and 5, and 1 and negative 5, and uh-oh, that's all there is, because it's a prime number, right? So, which one of these adds up to 2? Neither of them. What am I going to do? Oh no! Luckily, I'm about to introduce to you a new method which can handle not only this, but many other polynomials, many other quadratics. And I propose to you that you can take any quadratic like this and express it in an equal way, thusly. You can say x plus something squared plus something else equals 0. And that this is the same as this. Okay? And I'll show you how you do that. First of all, let's not talk about this with the exponent. To be very clear and transparent, which is the same thing, we can say x plus something times the same thing, x plus something, where these somethings are exactly the same number, okay? Because we're squaring. And we know from our first outside-inside last FOIL technique that this middle term, its coefficient is going to be this plus this, right? Just like we were doing with factoring or with FOIL. And we also know that these two numbers are the exact same number. So if these two numbers add up to this, then each one is just half of this, right? Half of 2 is 1. 1 plus 1 is 2. What a crazy idea! So then, basically, we have, if we multiply this together, x squared plus 2x plus 1. What are we going to do about that? Well, let's do this. First of all, just to make things easier, let's move the 5 over to this other side. And we have x squared plus 2x, we'll leave a little space, and say equals 5. Okay? Well, we can put a 1 in here, plus 1, if we put a 1 over here, plus 1, right? Not breaking any rules that way. And then we just came up with this square. This is actually x plus 1 squared, right? So we can say that now. As long as we've got this 1 here, and we've added the 1 on the other side, now we can say this equals 5 plus 1 is 6. And this is what we call completing the square. And this is our new method, our new tool in our box. Okay? How does that help us? Well, now we've got a square on this side and a 6 on this side. Let's take the square root of both sides. And we'll get x plus 1 on this side. And we'll get plus or minus, don't forget to say plus or minus, the square root of 6. Right? And now I've got a 1 that I need to get rid of, because I want to find out what x is. So I subtract 1 from both sides, and I get x equals -1 plus or minus the square root of 6. And notice that I still have 2 answers, just like I did when I was factoring. And I'll show you, you're not always going to have those 2 factors. You're not going to always have those 2 answers, but in this case you do. Let's look at an example really quickly of when you would not. What if this was, let's change this a little bit with another pen perhaps. If this were not -15 but +15, then this would still be +5. And when we move it over here, it would be -5. And this would not be 6, it would be -4, right? And then this would not be plus or minus the square root of 6, it would be plus or minus the square root of -4. Uh-oh, I can't do the square root of a negative number. That's not a real number. Now, a few steps forward in your math education, you will learn that there is a number that we talk about that's the square root of -4. Specifically, there is a number we talk about that's the square root of -1, which we call I. And guess what I stands for? It's imaginary. See, mathematicians have imagination too. But even though it's called an imaginary number, isn't that a cute name? It's a very useful number, and if you ever become an electrical engineer, you're going to use it all the time. And if you ever have to, predict the rate at which, let's say you design a snowplow, and you're predicting the rate at which it slows down as it piles up more snow in front of it, and you're trying to figure out, how can I make a snowplow that's going to get the job done on time? Then you're going to talk about I. So it's got lots of real functional uses. But for now, we just have to remember that if you wound up with this, you would have 0 answers. 0 real answers. There are imaginary answers, but they're not real answers. If you had a positive 15 up here, then you would have 0 answers. So this is a bit of a departure from factoring, because factoring will always give you 2 answers if you can factor it. And this will give you up to 2 answers, but it might only give you 1 answer and may give you no answers. Okay? So, having looked at that, let's now think about this in a more generalized form. Specifically, what can I use this for every kind of parabola, for every kind of quadratic I have? Let's find out. What if, for instance, what if we look at ax squared plus bx plus c, where a, b, and c could be any old integers, okay, or any old numbers. Can I do the same thing for anything that I come across? Well, let's find out. What will we do? Well, first, remember we had a 3 over here before. We divided the whole thing by 3. Now we're going to divide by a. So we have x squared plus b over ax plus c over a equals 0. And the next thing we did Well, just to keep things clean, we moved, this was a 5 before, but now it's c over a. We moved it over here. Let's do that again. X squared plus b over ax, with a little space, equals negative c over a. And gosh, I hope that c over a was a negative number. Otherwise, we're going to have a problem when we get a square root later. We might not have any answers. But for now, let's not worry about that because this is general. And we need to now complete the square to get this. So we're going to take this middle term, or this x coefficient, and we're going to divide it by 2. That will yield x plus b over 2a squared. And remember, if I then calculate this square, I'm going to wind up with a last term that's this squared. So I have to add that here, plus b squared over 4a squared. If I add it here, I have to add it here, plus b squared over 4a squared. And I might as well just bring that down then, because this is equal to this, right? So equals negative c over a plus b squared over 4a squared. Now let's start to simplify things. Let's add these two fractions together. In order to do that, I need to have common denominators. So I have 4a squared over here, I only have a over here, so I have to multiply this by 4a to get 4a squared. And I have to multiply the top and the bottom by that. So what I wind up with is negative 4ac over 4a squared plus b squared over 4a squared, which is negative, well, let's switch this around, save some ink. B squared minus 4ac over 4a squared. Yeah? And that's all equal to this square that I completed all by myself. Now, what I want to do is get rid of this exponent. So I'm going to take the square root of both sides. So on this side I get x plus b over 2a. Remember, our goal is to get the x by itself. That's what I'm working towards. So I'm going to try to take all this other crap off of it. So first I'm taking the square root on this side. And this side I'm going to say plus or minus the square root of b squared minus 4ac over 4a squared. Now notice, if you will, that this 4a squared is just the square of 2a. So I can pull that out of my square root. Thusly, this is all equal to plus or minus the square root of b squared minus 4ac, all of that over 2a. Okay? Now, I'm trying to get my x by itself over here, so I'm going to subtract this b over 2a from both sides, and I'll get x equals plus or minus, let's do this. Let's put it in front. So we're going to say this is x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And hey, this is convenient, they're both over 2a, which means I can add these together to get x equals negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. And this is the general answer for any quadratic equation. And it's so famous it has its own name. It's the quadratic formula. And you should memorize it. But more important than knowing it, because you can memorize it, but after a few years, if you haven't used it for a while, you're going to forget to put a negative here. Or you're going to forget that this b is squared. or you think, is it 2a or 2c? I can't remember. More important than memorizing this is remembering the method that you use to get to it, this completing the square method, which has multiple uses. You can use it in other situations other than just, in fact, we're going to talk about one later. It's useful for solving a quadratic equation, but it's a nice method to have in your toolbox. However, if you want to memorize this, there are countless songs, most of them very bad, that mathematicians have made up about it to help you remember it. The one that comes to my mind is, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Pop goes the weasel. But notice that there's no rhyming in that song, so it's not necessarily going to help you remember it. But sometimes when you put music to ideas, it does help you remember it. Plus, if you sing it over and over again, it's just like repeating it and it'll help you memorize it. But again, more important than memorizing this is to know how you got it. And if you're tested on this in a class that I teach, probably at least at the very beginning, before I know that you understand how to complete the square, when I ask you to solve a quadratic that requires completing the square, I'm going to expect you to show your work in completing the square and not just plug it into this formula that you memorized. Because if I'm teaching you math, I'm teaching you how to think mathematically. I'm not teaching you how to memorize stuff, because any old computer or calculator can do that. I'm not teaching a calculator, I'm not programming a calculator, I'm teaching a human being. And you, if you want to get good at math, need to think mathematically, not just memorize things. Okay. So this is completing the square. Anything else about that? Oh, I did want to look at one more thing, which was, remember when we were looking at this, let's look at our real example. And remember it was 3x squared plus 6x minus 15 equals 0. And remember that we simplified that by dividing by 3 to be x squared plus 2x minus 5 equals 0. And remember that after I completed the square, I wound up with the solution being x equals -1 plus or minus the square root of 6. Okay? Now, remember we had troubles factoring this because we couldn't think of any integer factors of 5 that would add up to 2, of -5 that would add up to 2. When we're doing our factoring method, we're only looking at integer factors, and I want you to keep in mind that there are a lot of factors. There are an infinite number of factors for -5 that are not integers. Yeah, you just have -1 and 5 and 1 and -5 as integers. But you also have, 1/5 and -25 and 1/20 and -100. There are an infinite number of factors if you include non-integers. And in fact, remember when we're factoring, we get x plus something times x plus something else equals 0 to get our two answers, right? And we just happen to have two answers here. What happens if we plug those two answers into this? Let's find out. So remember, these are not our answers but the negative of our answers, because if this is 0, then x equals the negative of this, right? Because we have to move that to the other side of the equation. So if I take this and I apply it negatively to these places, I'll get x plus 1 instead of -1. We'll do minus square root of 6 the first time. And then this time we'll say x still plus 1, but now we'll do plus the square root of 6. Okay? And this equals 0. What happens if we multiply this out? Well, there's a lot of FOIL involved in that. For now, let's just think of this as one thing and this is another, so we do the FOIL like that. And we'll get x squared plus x times this, so we get x plus square root of 6x, yeah? Then we gotta go, we just did outside, we're gonna do inside now. X times 1 is x times negative the square root of 6 is negative square root of 6x, right? That's our inside. And our last is yet another instance of foiling. So we're going to do 1 times 1 is 1. 1 times square root of 6 is square root of 6. And 1 times negative square root of 6 is minus square root of 6. And then negative square root of 6 times the square root of 6 is negative 6. Okay? That's a long thing. But let's simplify. It's pretty easy because here's a positive square root of 6, negative square root of 6. That cancels. What else we got? We have positive square root of 6x and negative square root of 6x, so that cancels. And what do we have left? We have x squared plus 2x. And we got 1, and we got negative 6. So we have negative 5. That looks familiar. It looks familiar because it's what we started with. So we just verified that these two solutions are the factors that we were looking for that were non-integer factors, if we had been looking for it. Of course, no math teacher is going to tell you factor this polynomial using non-integer factors because there are an infinite number of them. You can't just make a list of them because we're not immortal. You are going to die someday. But I want to point out to you that you're doing the same thing. You're finding the same answers. You're just taking a shortcut from counting from 1 to infinity and checking all those out. Okay? That's completing the square.